This is an example video on the chain rule, and specifically in this set of examples, I'm going to focus on problems that have either the product rule or the quotient rule involved in them with the chain rule. So I tried to write some kind of really hard chain rule examples in hopes of really helping you wrap your head around it. So I have guided notes on this. I highly recommend that you go to divideandconquermath.com if you want to kind of follow along. But these are the three problems I'm going to go through. Now, if you want to get the most out of this video, I actually recommend that you pause and try these three, see if you get stuck, and then you can review the answers. That's my 2 cents. But otherwise, I'm going to jump right into this. Okay, so starting with A here. So I've got sine of 4x minus e to the tangent x over secant of 3x minus 1 minus x to the 7th plus 9, and all of that goes to the 8th. Whew, that's a mouthful just to think about it, right? So this is really going to help you focus in on like how do you go about taking the chain rule. So in my eyes, the function that's kind of dominating all of this right now, the outermost function is this thing to the 8th. So I'm not even going to worry about the rest of the inside. Like basically the way I see this right now, this is all just inside function, all of this. I see that I have more chain rules to take in here, but I can't really do anything until I deal with this outermost function. So that's where I'm going to start. So I'm going to kind of color code this so that you can follow along. So I'm going to use the power rule. I'm going to bring the 8 down, and then all that stuff on the inside, I'm going to leave it as is. I'm not going to touch it because I'm just focused on that green outer function, okay? So let's see, I'm just restating all of this. Okay, and now I have taken the derivative of the outside function. So I am done with this outside part. And now I need to pivot to the inside. And all of this is the inside. And yes, I have to take the chain rule or use the chain rule a bunch. But ultimately, this is using the quotient rule. This whole thing is going to be dictated by the quotient rule. So what I want to do then is I want to multiply this by, and I'm going to just start working on the quotient rule. So as I move along now in the quotient rule, first I have to take the derivative of the top function. However, as I take the derivative of the top function, this I'm going to have to use a chain rule on. So let's see, I'm going to probably need a whole lot of space here. But, all right, so sine will be my outermost function, and this 4x will be my innermost function, okay? So taking the derivative of the outermost function, that will be cosine. And again, I leave that inside function intact. And then I multiply that by the derivative of the inside function, which will just be 4. Okay, so that's the first part of this, all right? And then I move on to taking the derivative of this. And again, I'm going to have to use the chain rule. Now, the outermost function here is e. The innermost function is the tangent of x, okay? So taking the derivative of e is just e. And again, I leave that inner function intact. But then I multiply this by the derivative of the inside function. The derivative of tangent x is secant squared x. And so this is the derivative of that top part. And then I multiply that by the bottom function. So you've really got to kind of remind yourself, what is that quotient rule and are you honoring all those parts of it? So see, I'm going to have to really cram here. Okay, so there's the first part, all right? And then, let's see, this parenthesis here, this is just going to be very long, so I'm just going to erase this for right now. And we'll figure out what to do with that in a second. So then I need to pivot and now take the derivative of the bottom function times the top function. Now just so that I don't forget, I'll go ahead and just write out the top function. So this will be minus sine 4x minus e to the tangent of x. And now I can work on this bottom function derivative. So let's see, I'll just open this up. Okay, so as I take the derivative here, so my outermost function is the secant function, and then the inner function is this 3x minus 1. So the derivative of secant is secant tangent, but where I had an x, now I'm going to replace it with the inside function. So this is going to be very, very long and messy now. So this will be secant 3x minus 1, tangent 3x minus 1, and then I multiply that by the derivative of the inside function. So that was 3x minus 1. The derivative of this is just 3. Whew. Okay, and now I continue on taking this derivative. So then the derivative of x to the 7th is going to be, minus 7x to the 6th. And the 9 drops out. So there's all the pieces of that derivative, right? And then all of that is divided by the denominator, squared. So definitely a nasty derivative, right? So as far as like how do you even go about simplifying this? So this is going to be one of those ones where there's like not really a lot of simplification. So really I can just like kind of put like some of these constants in front, but otherwise there's just not a whole lot of simplification. So I'll go ahead and simplify this, and then I'll just show you what the final answer would be. So for the sake of space, let me actually get rid of the original problem just so I can focus on this bottom part. I'm running out of space here. Okay, and so really what my goal is going to be now is to just kind of get everything under, like, so as one fraction. So just FYI, the way that I'm going to break this up, I'm going to break this part here up into two pieces. So the top to the 7th and then the bottom to the 7th. So you'll see me kind of rearrange that in a moment. So actually, I guess I'll just do this. I'll do this with you guys so you can kind of see how I'm thinking about this. Okay, so as I go through this, so I'm going to start with this part 8, and then sine of 4x minus e to the tangent x. So this to the 7th, okay, and then this is going to be multiplied by all of this stuff here. So it's going to be a little bit of work. So let's see. This will be 4 cosine of 4x minus e to the tangent x secant squared x times secant 3x minus 1 minus x to the 7th plus 9 minus sine of 4x minus e to the tangent x. This times, let's see, this will be 3 secant 3x minus 1 tangent of 3x minus 1 minus 7x to the 6th. And then here's the sorcery I'm going to do here. Okay, so remember, we have this denominator to the 7th, and that's actually the same denominator here. So notice those are the same like base, so I can add the exponents. So in the denominators of all that stuff that I can't even fit on screen, and then secant 3x minus 1 minus x to the 7th plus 9, and then I take the 2 plus the 7, and this will be to the 9th power. And so that's really like as good as it gets. And oh, actually, you know, I did make like a slight tactical error here. This 8 and this part here, this needs to be multiplied across the entire top of the denominator. So the last adjustment I need to make here, this needs to really be multiplied by all of this. So there's a little bit of a parenthesis nightmare, I guess you could say, but this part here was intended to be multiplied across all of this. So hopefully that makes sense. And okay, so that is really as good as that one gets. This one was intended to be intentionally nasty. All of these problems are kind of intended to be intentionally nasty, so that the answers could be pretty nuts as we go through them. Okay, so moving on to B here. So I've got f of x equals sine of 5x plus 1 times e to 4x minus cosecant of x cubed minus 2x. Okay, so looking at this, again, you see all these chain rules here, but like ultimately what's going on here, I've got this function, so maybe I'll underline it, this function times this other function. And yes, we'll have to use the chain rule, but like where we need to start is with the product rule. So, product rule. I need to take the derivative of the first function and then multiply that by the second function. So first we're going to work on taking the derivative of this. So let me kind of reset these. So the outermost function here is the sine, and then the innermost function would be this 5x plus 1, right? So the derivative of sine is cosine, and I leave that inside function intact, and then I multiply that by the derivative of the inside function, which is just 5. But then remember, I have to multiply this by the other function, e to the 4x minus cosecant of x cubed minus 2x. Okay, so that's part one. So now I leave the first function alone, and I'm going to multiply this by the derivative of the second function. So now I have e is my outermost function, and then all of this is the inner function. Now I see that I'm going to have to use the chain rule again, but I'm going to worry about that when I get there, okay? So this will be e to the 4x minus cosecant of x cubed minus 2x, because the derivative of e to the x is just e to the x, except you leave the inside function intact. Now I need to multiply this by the derivative of the inside function. So let's see, I'll write that there. All right, so the derivative of 4x is 4. And then, and then I come to this next part here. So the outermost function here is cosecant, and the innermost function is this x cubed minus 2x. So now I've got to kind of start the process over. So the derivative of cosecant is negative cosecant cotangent. So what I'm going to do then is I'm going to change this to a positive. So this was negative, so now it will be positive. So this will be cosecant cotangent, except where there was an x, now I'm going to replace it with that inside function. So cosecant cotangent. And then I multiply that by the derivative of the inside function, which will be 3x squared minus 2. Now I'm done. All right. So how do we simplify this? So there's not a whole lot of simplifying to do here. I would just rewrite this as 5 cosine of 5x plus 1 e to the 4x minus cosecant of x cubed minus 2x plus, yeah, there's not a whole lot we can really do to simplify this, so this will just be sine of 5x plus 1 e to the 4x minus cosecant of x cubed minus 2x times 4 plus, let's see, I'll just move this 3x squared minus 2 in front to make it look nicer. And this is cosecant x cubed minus 2x cotangent x cubed minus 2x. And I think I got enough parentheses. Okay, so that's it. So again, same theme, right, of like kind of a nasty derivative, very long. It's just going to have a lot of stuff in it, but if you're getting the pieces of this, then you're really zeroing in and understanding kind of how and when to apply the chain rule. All right, so if you haven't tried any of these on your own yet, this is by far the mother of nasty derivatives that I could come up with, because I threw the quotient rule and the chain rule and the product rule all into one problem. So this one is going to be definitely pretty nasty. I'm not even going to simplify this one. I'm just going to show you how to set this one up, because I don't think I'm going to have enough room on screen, to be honest with you. So, okay, if you haven't tried this one, I highly recommend you pause here. Okay, so I'm going to start it. So the outermost function kind of dictating everything here is just this thing to the 9th. And as you know, if you've been watching my videos, I like to kind of attack from the outside in. So I'm just going to start there. This becomes 9 sine of 4x. So I leave all that inside stuff intact. I'm not even thinking about it. Not letting it give me any anxiety, because I just need to take the derivative of the outermost function right now. Okay, so there I've taken the derivative of the outermost function. So now we can focus on the next part. So again, you really want to like have your plan of attack here. So this is ultimately a fraction, so I have to use the quotient rule to kind of take care of this. So in using the quotient rule, I need to take the derivative of the top times the bottom to start, right? So now I got to think about taking the derivative of the top. And so as I look at this, so this is where this gets super nasty. I notice I'm going to have to use the product rule here and the chain rule. So I really tried to make this as terrible as I could. So let me know in the comments if I accomplished that. Okay, so let's start by, so I've got this function and this function. So I don't really think about anything else right now, just to kind of get this started. So this will be times, we're just working on the top part. So I need to take the derivative of sine of 4x, recognizing the outermost function is sine, the innermost function is 4x. So the derivative of sine is cosine, and I leave the inside intact. And then I multiply that by the derivative of the inside function, which is just 4. And then I multiply that by e to the 5x. Okay, so that's the first part of the product rule, right? Now we pivot. I leave the sine of 4x alone, and now I need to take the derivative of this e to the 5x. And if I just kind of investigate this, e is the outermost function, 5x is the innermost function. So the derivative of e to the x is just e to the x, but now I'll write this as e to the 5x, and then I multiply that by 5. So now I've taken the derivative of this guy, except I still have to take the derivative of this x cubed. So now plus 3x squared. So all of this was the derivative of the top. Remember, we're using the quotient rule here. So then I have to multiply that by the bottom function. So that is going to be multiplied by, and let's see, I think I actually need a second set of parentheses here. I'm going to put big set here. So, okay, so now this will be this times x minus 7th to the 4th tangent squared x. So there is now the first part of my quotient rule. This derivative times the bottom. All right. Next, now I leave the top function alone, and this will be sine of 4x e to the 5x plus x cubed. So all of that times now the derivative of the bottom function. And now we have to use the product rule again, and we have a whole bunch of chain rules in here. So again, I spared no mercy on this one. So in looking at this, so let me just kind of focus in on this for a moment. So the two functions we have here are this x to the 7th and this tangent squared x. So I have to take the derivative first of this x minus 7 to the 4th, recognizing that the outermost function is this thing to the 4th, and the innermost function is this x minus 7. So taking the derivative of the outer function, let's see, I'll set up some parentheses here. So this becomes 4 times x minus 7 to the 3rd. And then I multiply that by the derivative of the inside, which would just be 1. So if you include that or not, that's okay. And then remember, I multiply that by the tangent squared x. There's the first part. And now I leave the first function alone. And now I take the derivative of tangent squared x. And I threw this one in here just to kind of remind you guys. Remember, tangent squared x is equal to the tangent of x squared. So the outermost function here is this thing being squared, and the innermost function is this tangent function. So this will be times 2. Remember, we leave the inside function intact. I don't have to subtract, well, I can subtract 1, but I'm just not going to write anything here. And then I multiply that by the derivative of the inside, which is, let's see if I can squeeze that in, secant squared x. And that is the second part of my quotient rule. Okay, so I just want to kind of point out here, so we have, maybe I'll use another color. Let's see, I'm actually running out of colors here. Okay, so I have this part here all the way to really this part. This was taking the first derivative times, or the derivative of the top times the bottom function. And then, let's see, I'll just accentuate it here. This part here to this part here, this is the top function times the derivative of the bottom function. So I'm almost there, and so now I need to divide all of this by the bottom function squared. And So all of this, so really all of this, let's see, I'll put a big bracket here. And I had this orange bracket. I had this orange bracket out here. All of this gets multiplied by this thing here. So this is, like I said, it's kind of a nightmare to simplify. And it's not really like the most meaningful simplification. So I just wanted to kind of get all those pieces out there. If you got all the pieces right, I think that's a great sign. And I think that shows that you really kind of understand how these work. So I know this video is really tough, but hopefully that really helped you to kind of figure out some things with the chain rule. Feel free to leave me a comment or a like or hit the subscribe button. That really helps me out. And otherwise, thanks for watching, guys. I'll catch you next time.